Welcome to CBSEasy.
All right, welcome back. Today we're going to go on a bit of a code-breaking adventure, right into the heart of polynomials. Our mission? To crack their secret code. Okay, so let's just jump right in. You've probably seen it before, right? You look at this kind of complicated polynomial formula, and then you see its graph, all these beautiful curves, and you have to wonder, how are these two things actually connected? Like, how are they secretly talking to each other? Well, that is the hidden link, the code that we are here to crack today. You know, to crack any code, you've got to know the suspects. So before we get to the big secret, let's get properly introduced to the key players in our little mystery, the polynomials themselves. So, first things first, what is a polynomial? Anyway, let's forget the textbook definition for a sec. I want you to think of it like a recipe. You've got your main ingredient, the variable, we'll just call it x, and then you have the coefficients. Those are the numbers out in front, and they tell you the amount of each ingredient to use. Simple as that. Now, every good recipe has that one key instruction that kind of defines the whole dish, right? Well, in polynomials, we call that the degree. It's literally just the highest exponent you can find attached to a variable. This little number, well, it's the boss. It calls all the shots, dictating how complex the polynomial is and what the final shape of its graph is going to look like. And this is a great way to see how the degree changes everything. If you have a degree of 1, you get a linear polynomial. That just makes a simple straight line. But bump that degree up to 2, and now you've got a quadratic. And that's when things start getting curvy. And if you go up to a degree of 3, you get a cubic, which, as you can see, can have even more fun twists and turns. Okay, look closer at those letters in the formulas, the A, the B, and the C. These are our coefficients. And you're gonna wanna pay really close attention to these guys because they aren't just some random numbers. They are the secret keepers. They hold the key to this whole thing. All right, so every good detective story, it kicks off with finding that first big clue. For us, that first clue is something called a 0. So let's put on our detective hats and go on the hunt. So this 0, what's the deal with it? Think of it as a magic number. It's that one special value for x that when you plug it into your polynomial recipe, the whole thing just poof equals 0. It's the magic input that zeroes out the entire output. Okay, that's cool in theory, right? But this is a visual explainer. What does a 0 actually look like when you graph it? How do you spot one in the wild? Well, here it is. Geometrically speaking, a 0 is just the spot, the x-coordinate really, where the graph of our polynomial actually hits or crosses that flat, horizontal x-axis. Seriously, every single time that curve touches that line, boom, you've found a 0. Let's just focus on our quadratic polynomial for a second. Its graph, which is a parabola, can do one of 3 things. It might swoop down and cross the x-axis in 2 completely different spots, giving you 2 different zeros. Or it could just kind of gently touch the axis at one single point. Or, and this can happen, it might float completely above or below the x-axis, never touching it at all. In that case, it has no real zeros. You know, the easiest way to picture this is to imagine the graph is the path of a ball you've thrown in the air. Finding the zeros is exactly like finding the points where the ball hits the ground. And this brings us to a super important rule of thumb here. The degree of a polynomial, remember that highest exponent, it tells you the maximum number of zeros it can possibly have. So a quadratic with degree 2 can have at most 2 zeros. A cubic with degree 3 can have at most 3. See the pattern? The degree always sets the speed limit, so to speak. Okay, people, we've met our suspects, the coefficients. We found our clues, the zeros. Now, this is the moment we've been waiting for. It's time to reveal the code. So, here's the big secret. Turns out, our secret keepers, the coefficients, and our clues, the zeros, they aren't separate things at all. The zeros, let's just call them alpha and beta for now. And those coefficients, A, B, and C, they are directly and kind of beautifully connected by a simple and elegant mathematical code. So this is it. This is the code. For any quadratic polynomial you can think of, no matter how complicated it looks, if you take its 2 zeros and add them together, the result will always, and I mean always, be equal to negative b divided by a. And if you multiply those same 2 zeros, the result will always be c divided by a. It's this amazing hidden rule that's underneath it all. Look, a code sounds cool, but it's totally useless if it doesn't actually work, right? So let's stop talking theory, let's put this thing to the test and verify it with a real, live example. So let's grab a test subject. How about the polynomial x squared plus 7x plus 10? So for our code, that means our a coefficient is 1, b is 7, and c is 10. Got it? All right, let's break this down together. First, we find the zeros the old-fashioned way. If we factor this polynomial, we get x plus 2 times x plus 5, which means our zeros are -2 and -5. Okay, now let's check them. The sum of the zeros is -2 plus -5. That's -7. The product is -2 times -5. That's 10. Now let's try the secret code. The sum is supposed to be -b over a, so that's -7 over 1, which is -7. Yep, perfect match. The product should be c over a, so 10 over 1, which is 10. It works. Another perfect match. The code is real. And listen, this is way more than just a cool party trick to check your homework. This relationship is so powerful, we can actually use it in reverse. We can build a polynomial completely from scratch just by knowing a little bit about its zeros. So how about this? I'll throw a little challenge your way. Can we actually build a quadratic polynomial where we know the two zeros add up to 4? And when you multiply them, you get 1? Let's give it a shot. Okay, so we just need to use our code, but kind of work backwards. We know the sum, which is 4, has to be equal to our little formula, -b over a. And we know the product, which is 1, has to equal its formula, c over a. All right, let's just make our lives easier and say a is 1. So if -b divided by 1 equals 4, then b has to be -4. And if c divided by 1 equals 1, well, then c has to be 1. We just plug those values, a equals 1, b equals -4, c equals 1, into the general form, and bam, there's our answer. X squared minus 4x plus 1. We literally just built that from scratch using only the secret code. So today, we did it. We cracked the code that connects a polynomial's formula to its graph. It just goes to show you that underneath all the complex-looking equations, math is just filled with these incredible hidden patterns. And that just leaves me with one final question for you. What other secret codes are out there just waiting for us to discover them?
Thank you for watching with us. See you next time.